So for more immediate assistance, you can send that 911. There is a third assignment and then a solution that we want to engage between now and the start of next week. So by the time we hit class on Tuesday, you'll need to be complete with the third assignment. And why are we running more points? Well, we're not doing a midterm, right? So as a class, we decided that we were going to run a little lower weight on the final exam. We weren't going to have a midterm, and I think, didn't we do a chat where I asked you to chat to me? You know, do you want 25% of your grade to ride on the final exam or 20% because we weren't going to do a midterm? Does that ring a bell for anyone?
Yeah, we
I
did
remember
that.
something like that.
Yeah, you did that. And I remember logging the results, right? So everybody had a chance for input. And so here's where we are. We have to clear the next. So we're in coding and database essentials. By the time we start next Tuesday, we have to be into the data pattern recognition statistics, essential statistics, right? We're going to get into some statistical things. And then the last, so we're going to run with 5 modules instead of 6. I'm refactoring the content so we finish at the end of the 5th module. So by Tuesday, 12 noon, I'm going to be introducing material for things like standard deviation, right? Just to work some quick methods. And then the week after that, we're doing some data mining and simulations. We'll be doing some Monte Carlo stuff. The last day of class is the 24th or 25th of this month. And it's the 5th of November. So if we had any extra runway or latitude, we kind of played it out. But so the goal today is to get everybody in a good place before the day is done with assignment 3.1, and then within 24 hours of now to get this next one in. But I wanted to talk to you about the turtle sighting database, right? So I wanted to pull up some quick screens and walk through some access concepts. And I wanted to talk to you about what's expected here. And the reason that you have an extra assignment here, and the first assignment is weighted a little more than a 1-point assignment, is because we're making up for not taking the midterm, okay? But we have to take up the slack in some form or fashion. There is a YouTube video, and it's one of the first ones that I pushed out to YouTube when I did not have proper equipment or a dedicated microphone. And you're going to hear, this is embarrassing, but you're going to hear a laptop fan clicking in the background. But it's not so loud that it causes a problem. But it's a 20-minute video, and it walks through how to build this thing from start to finish. So if you spend 20 minutes watching this, and then, right, you look at this one. In the video, the resolution isn't so good, but I have high resolution screenshots that are step-by-step tasks of what's in the video. So actually, once you watch this, if you open this and then start with access on your screen, you should be able to just build it. Criterion 1, 2A, and 2B are the 3 screenshots. They're examples or samples of the screenshots. And observers.txt and turtles.txt are going to be used to import data into the database. So I've basically done some of the shortcuts for you. You don't have to build a table and then populate it with keyboard entries. You just suck this thing in with a data import. I'm going to show you how to do that in a minute. And then you go from there, okay? So do we have any questions so far? And then, by the way, we want this by 11:59 p.m. Saturday, because you want like Sunday for a breather or Saturday for a breather, and then based on the stuff in the study guide, you want to have the assessment finished for this module by 12 noon on Tuesday. Okay? Everybody with me? Kind of, sort of. Any questions?
Yeah, sounds good.
Okay.
I didn't go through this, so I'm gonna go through it and then see what we need. I didn't know we had this to do yet.
I just put this out early this morning.
Okay.
The goal was to get 3.1 and 3.2 on deck so I could get some quick turnaround on that with you. And so we did have a quick question about the Python. And essentially, I wanted to explain to people that there's two modes of operating with Python. So where is my, oh, that's not it. Everybody see the three red arrows?
Yep.
Three right?
Yes.
Three right arrows. So this is what I hate about, well, sometimes, you know, I'm really, if you work 20 years in industry and then you see code like this, you're like, who taught you this? Oh, I'm a graduate of MIT, right? So here's an MIT professor that wrote this textbook, and this is the example he's showing. And he's using a single letter, lowercase I, to represent an integer. And that's kind of obvious. Instead of using a descriptive name like INT temperature, right? Something like that. The point I'm trying to make is you could easily put in 2.345, and I'm going to do that in a second, in interactive mode in Python. And you're going to find out that I get a different answer here. And so a single letter doesn't help you when you're debugging, when you're troubleshooting why your code doesn't work, right? So if I mix this up, I mean, presumably we're using lowercase r because this is a real number or a floating point number, right? And then we do type r, and then that gives us back the data type that it is. And so it's really important to understand the basic data types. Boolean is true or false, sometimes represented 1 or 0, 0 being false and 1 being true. And so you have these different, very few, but I want you to know the basic data types. Let's get into our screen here. So when you're doing when you're doing those exercises with YK, the benefit of Anaconda is that Anaconda is operating in interactive mode, and there's airbags and safety belt. So when you enter certain commands for Anaconda, you see the results instantly, where normally in interactive mode you may not. But let's just do this. So to enter interactive mode, I'm going to type Python. And now you have the three. Can everybody see this?
Yeah, I can see it.
Okay. So I'm going to arrange my screen here if I can. By doing like this. There we go. We can see both together. Yeah. Does everybody see what I just did there? How I organized the screen like that? Should I do it again?
Oh, I know how to do this.
Okay.
Yeah, this is
Like you pull it to the right or left, and then it will give you option to
Yes.
pull up a next tab.
So originally I had multiple tabs. I dragged the tab down. Now it's isolated in a window of its own. And I grabbed this thing in the center and I threw it to the right. And if you throw it off the screen far enough, it takes up exactly half the screen. And then when you click on something else, it automatically sizes to take that part of the screen. Now, why do you care? if you want to work more efficiently and you don't want to be cussing me out by Thanksgiving, please, I want you to try this, because there's going to be a lot of stuff where I show you a screen and then I need you to do a thing on your screen, and I show you a next thing and then you got to do it on yours. And I wanted to take the time to show you how to work in this fashion. All right, so I'm going to use this example here, right? I equals 1. Okay, I got no error. That's great. That's a good sign. I'm going to put in type, and then I'm going to put I, because I've stored the value I into the variable I've named I. And now I'm putting I in the argument or attribute that I can use for the type function. So this idea of functions is that you have data elements that you can input into a function, and I want you to see this. That's part of explaining how functions work, and for people who have already had computer science courses already, I'm so sorry. But I'm doing this for the folks who haven't had any. All right, so I hit enter, and it says class int. Now let's mix it up. Let's say that I was mindless and I chose my variable names rather poorly, and I tried to repeat the same thing like this, and I said 2.345. Well, now I've stored the value 2.345 into the variable I, which presumably means integer or whole number, except I'm kind of dorky here on purpose. And I'm going to repeat my command by using the up arrow. So I want to run that variable through the type function. And now it says float. So what am I saying? If you don't label, if you don't choose variable identifiers or names, right? So the technical term is identifier. A variable identifier is a label or name for a variable. If you don't choose that on purpose, then you get into trouble later when you have problems. Because if you mix up data types, I'd be willing to bet that 15 to 20% of like all buggy misfire errors are simple things like misspellings or data type. You're not minding the data type. So what I'm going to do here is go integer. I'm going to use int, and I'm going to say outside temp equals, let's say it's 78 degrees, right? So I've done the same command as I equals 1, except I've gotten a little more elaborate. And it still works. So the thing I want to impress on you, I want to intentionally take a little bit of time to show you, and this is what I meant in my assignment. You know, take a little bit of time on the assignment here. It says take a little time to make your own example of the variables, right? When you're walking through the examples with YK. Now, am I going to deduct if you don't? No, I won't. I'm not requiring you to use one. I just said take the time to do it to practice. I want it to become a practice for you, because when you get to these other things, these other types of coding methods, that habit's going to pay for itself, okay? So now if I repeat, and I want to know whether or not the rest of it works, okay? You'll notice I don't have I this time. Or actually, couldn't I just say I and hit enter again? Okay, so help me troubleshoot. What's going on here? What should I be putting in type?
You need to put the full variable name.
Exactly. Now, what I'm trying to impress on you is that if you have a function, and let's pretend it's not type, but it's a function, and then you have to put something in there as an argument or, you know, an input for the function, right? if you've labeled it well, you know what's going into the function. So when you get an error message, it's easier to figure out what went wrong. So if I do int outside temp now, oh, I get the correct data type. It tells me that 78, what's stored in there, is correct. Does anyone know what we do for Boolean?
Zero or one.
Yeah. What prevents that from thinking it's an integer? Just a question.
The condition.
Yeah, you can. Yeah, you can use 1 or 0 depending on the programming language of what you're doing, but it's saying true is not defined. So how would I do Boolean? Does anybody know in Python?
Just assign it a true or false value, or you could do like you could either assign it the true or false value, or you could assign it like a condition. Like if you say 2 is greater than 3, that's false.
Yeah, so what you're doing is assigning a variable a value of 1 or 0, and then you're testing for the Boolean condition. Yes. Yeah. So there is a little more to it. The other thing I'd tell you is that the other thing I'm doing that's wrong, a lot of people start exploring and they try different things. And here's my problem. I'm still using like the same variable name for a Boolean value. So I'm basically trying to demonstrate all the things you shouldn't do. And one of the things you shouldn't do is reuse variable names. You should have unique variable names or variable identifiers for every specific use. And then that way you don't run into problems. Because if you change things and use the same name, it's easy to lose track of that. So I would, for Boolean, I could say boo. I could say a Boolean variable would be true or false or yes or no if it's raining, right? So you can get creative with this. I just wanted you to see what's going on. And again, this is interactive mode where you're entering a specific command, and then as you go, if you get into errors or you get into problems, it's just harder to follow the flow. It's easier in Anaconda to do that. Here's the second way you're doing it when you use nano, and then you save it with a .py extension. That's where the that's where this comes in. So you're using nano, and you're saving the content to greeting.py, and then you run Python greeting, and that executes line by line by line until there's no more lines. So instead of doing one line at a time, you're doing all the lines at once, and it's good to work in both ways when you're trying things out in interactive mode, and then when you know it's working like you're supposed to, then shift a gear and create a .py file using a text editor. Okay? So those are our initial recommendations, just in case. Those are some blanks that YK may or may not have covered. And I like the way YK presents that information. It's very efficient. I hope you've had a chance to just relax and follow along, and I hope it hasn't been too stressful. But there are 11 of these. If you do the other 8, you know 90% of Python. I'm just saying. So if you ever needed to do more Python, just remember this assignment and then go back and do the other. Okay. It's very useful stuff. Any questions about our coding interests? Does anybody have any questions about the assignment now that I've had a chance to share some things?
This was what was due today, right?
Yeah, this is.
Yeah.
I didn't have any problems with it.
Right.
Oh, I thought we had to do it in nano. That's what I was having an issue at first.
Oh yeah. Well, so nano The trick with Nano is that when you save, all right, so the other thing you might have to do is use a // when you're running things. But yeah, Nano can be a little tricky. Was there any specific, did you figure it out, or is there anything you want to show me about Nano?
Oh no, I got it. I realized it was like a character missing.
It is. Yeah, it's very, very character based. So it's a little bit like, there is another app. So I just wanted to share with you, if you go into here and then you look, there is text editor. And you can use text editor, and that's more of a GUI. That's more like Notepad in Windows. And so if you don't like using Nano, you might try using text editor. Any other questions before we, I'll just leave that open in case any other questions come in.
Yeah, when I was using Nano, then you create it, and then you exit, and then you click yes or save, or hit Y, and then there's a third option. Like, I think it was asking me to where to save it. I wasn't sure what the third prompt was when you're exiting it.
Okay,
After.
that's a good, I'll just do test.txt. Well, wait a minute, I better see if I have something in here called text. Yeah, I don't have a file named text.txt, so I'll Nano. So let's just say I have a single line, and now each of those caret symbols is the control key. And if you use the right control key, what may happen is that the right control key is the host key for the virtual machine, and it's going to trap that key press. And then when you press these other letters, it's going to think you're trying to do stuff like this, host T, N, S, whatever, blah, blah, blah. Okay, so you want to keep in mind what if you go down to the lower right corner, it'll tell you if the right control key or the left control key is the host key for your virtual machine. So I'm going to use my left control key to exit. So I'll press left control X to exit. It's going to say save modified buffer. I'm going to say Y for yes. I want to save what I did. Write the name to write, text.txt, yeah. I'm just going to hit enter. And now if I list it, it put it in the directory I was in. So the quickest and simplest way to structure your use of Nano is to get into the directory where you want the file to exist and then issue the Nano command. So everybody remember that we created a mod2 solutions directory?
Yeah.
Okay, so let's say I go cd mod2 solution. I'm in the mod2 solutions. If I go in here, I have test1.txt, right? So I don't, if I wanted to create a second test folder, I'd go nano test2.txt, and so I'm going to control X to get out. The other options, so the cut, the uncut, the replace, the justify, those are lower level text editor functions. I like keeping it simple, but I use arrow keys and I just enter and then X. I want to save what I've got so far. That's what save, do you want to save the buffer means. That's geek speak for, do you want to save what you've done so far? I want to write it to this file name. I can back over this and go, oh no, I want test3.txt, right? Or, hey, let's make it really weird. Let's do this. I'm going to put a tilde slash test3.txt, right? So the tilde means, oh, put it in my home folder, right? I'm going to hit enter. Save file under a different name. Well, it's asking that because I already have. I'm going to say no. I don't want to save it under a different file name. Yes. All right. I'll answer yes. If I look for it, I don't see test 3. I have to go back to my home folder. Now if I look for it, there's test 3. So just remember, if you want to put it in your home folder, you can use ~/. Does that help with the path thing somewhat?
Yeah, it answers the question where it like sends it to certain places.
Yes. All right, so let's look at our turtle database. Wait a minute. No, that's the solution. Turtle. Hold on. Oh yeah, there it was. I was going to say I had it right here. Okay, so we talk about the idea of dependencies and about the different types of relational operations. Does everyone remember what we were talking about on Tuesday? We were talking about
Yeah, the relationships.
right. Actually, it was the addendum. So we went into some details, but most of this is in the addendum. So restriction. So it's one thing to know the concept of restriction as a relational algebra operation, but in Access, if I have a query and well, let's take sightings. I'm just going to open up sightings as a table. Can everybody see the turtle species ID?
Yep.
Okay. So I'm going to look at my database tools and the relationships. I have two tables. I have a sightings table and a species lookup table, right? So how you decide to format the name of a table, a database table, can take a whole variety of different flavors. I talked about like using another convention in previous examples, but this works just as well. So I have a species ID, that's the key field. You have a common species name. You have the Latin genus species, right? And then we have the name of the turtle. Like when we see an individual turtle and it has distinctive markings and it's the only one of its kind in St. Thomas and it's 17 years old, then you might name it George, right? So you have a turtle name. Whoever sees it first, you'd have these ways to identify your turtle. You have a date time, you have the observer name, right? It's a very simple table arrangement. But if I look inside my sightings table, you'll notice it doesn't show the species in the sightings table. It only shows the species ID. It doesn't, so what am I saying? These are related we've taken the trouble to do the two things, entity relationships and database normalization, so that we have this we've organized this in a way where the data is not duplicated, right? So in my sightings table, I don't have turtle species names, genus species, I don't have that, right? It's not duplicated just because I have a sightings table that wants to include turtle species ID. What's more important too is this right here. So if I take, and let me look at this again. So I have a turtle species ID of 1, right? What I have is a way to do a query where both of these tables include all of their fields together. So I'm going to show you what that looks like in a minute. But basically, I can click this relationship and then edit the relationships where I can enforce the referential integrity. So this is something I mentioned in the study guide. If I have a dependency between two database tables because the information is only listed once, I want to make sure that there's an entry in that table where it's going to be referenced in another. What do I mean? If I have a turtle species ID of 2, but I don't have a corresponding entry to that in the sightings table, then I'm going to have a misfire when I try to query. It's not going to work right. Does that make sense? Kind of, sort of?
Yeah.
Okay, so which one's the primary key in this case? The turtle species ID in the species lookup, or the turtle species ID in the sightings table? Which one's foreign and which one's primary?
Okay, so sighting ID in the sightings table is the primary, and turtle species ID is a foreign.
You said this one here is the primary? The turtle species ID in this table is the primary?
Yeah, in that in that table, the sighting ID is the primary, and turtle species ID is a foreign key.
Okay, that's correct. Yeah. So this is the primary key in this table, but if I'm talking about this key, this is also a key. And because it's many, if it's 1 on this side, it means we don't have any duplicates. So that makes this the primary key. Anytime you have a 1, you're saying no duplicates in access. You're saying that's designating this as a primary key. This one you can have multiple entries, right? You can have multiple sightings of turtle species ID number 2. But when you check this box, you check all the boxes, what you're doing is you're saying, I want to enforce referential integrity. I want to account for dependencies. So I can't just remove fields or change database tables and then, oh, now I'm screwed, I can't look it up for a join. The other thing that I want to show you is this join type. In your textbook, it talks about tuples where the joined fields from both tables are equal. All records are tuples from this table and only those records from that table that are equal. And then the third option is all records from the sightings table and only records from the species lookup that are equal. So the join type here tracks with the concepts for join types we talked about where the Venn diagrams were concerned. Does everybody remember the Venn diagrams? On Tuesday, we talked about the Venn diagrams and how you needed the, there was one where only records that are common to both tables.
I remember those, yes.
Okay.
Yes.
Right. Okay. And that would be the join property number 1. That's the default. right? But you can change the join property and say, okay, now I want to include just this, just the ones from here that match. So you can basically tweak that, meaning you can switch between union and intersection and difference somewhat. Now, it's a quick generalization, but I wanted you to see how this looks in Access, how you can change some of those settings. Well, what about the restriction operation? Let's just give you a quick idea of how this would work. I'm going to create a whole new query with these two tables. So I'm going to create a new query, and I'll use the query wizard, and it's going to be a simple query. And instead of using queries of queries, I'm just going to select the two tables, sightings, and I'll do like this. But then I'll also select species, and I'll do like this. What did I just do? I selected the two tables one at a time, and I selected all the fields in both tables. And I want you to notice, here's the turtle species ID and turtle species ID, but notice how they're stated. This is from the T sightings table, and this is T species lookup. Does everybody understand that difference there?
Yep.
Okay. I'm going to give this a descriptive name, and I'm going to call it Q for query, right? And I'll call this full sightings. So if I put I want everything together. So what you see now is the sightings ID, the turtle species ID, the turtle name, and all this, but then over here you see the same thing again, right? See species lookup again. And that's what I wanted to show you. I have turtle name and turtle, I have turtle species ID and turtle species ID. Well, this is kind of chaotic. And what we really want to do is use restriction and projection. So I'm going to go into design view, and I don't want to see the second species ID, right? So I'm going to take the species ID here and the species ID here, and I'm going to unselect this one. That's the same as, it's like projection. So the action I'm taking in terms of the operations on these two data tables that are joined, I am selecting against this. Now, you shouldn't use the word select loosely. In your textbook, it explains that select is actually a SQL command, and it has to do with projection. So when I turn fields on and off, because I don't want to see them, I'm using projection. Okay? So how might this look? I'm going to go back to, I'm going to save this. I'm going to go back to datasheet view. That's a little cleaner, right? And let's pretend that I don't need to see the species ID. Okay. So, or let's just say I only want to see the green turtles. So let's talk about a case where we're restricting. If I'm using relational algebra to restrict, I'm really doing this. I'll go back into the design view, and I'll say criteria equals 2, because that's the green turtle, right? And that's all I want. And for that matter, I want to put the species common name and the genus species. I want to move it over here next to the species ID so it looks a little nicer. Everybody see what I'm doing?
Yeah, you're just dragging them across.
Yeah. Now, see, I've used projection because I'm taking out those fields, that set of records, that database table field, and I'm reorganizing the appearance, right? So if I save this now, and then I go to datasheet view, see here's, oh, citing ID number 4 was a green turtle. Do I really need to see the species ID number in order for this to be meaningful data in a report?
No, if it just says the green there, yeah. If it has a species name, then no.
Yeah,
Right?
that's correct. So isn't this kind of like isolating your data elements in the spreadsheet where you put the constants in the upper corner or left side? You're kind of taking it a step at a time to isolate the elements, right? So you can do this as you're doing queries. And what I like about this is the powerful part I want to show you. So we do this graphically, and I go back to design view and I say, okay, I don't really need to see the species ID, but I'm going to use it because I have to select, I have to filter, okay? So the term we want to use is we're selecting different fields, that's projection. We're filtering for specific records, that's restriction. So in Access, I'm performing both of those by taking these actions. So now if I save this and I go to datasheet view, what I get is the citing ID, the common species name, the Latin genus, right? The Latin name, genus species, right? Is that Chelonia or Chelonia? Biology folks, anybody?
I have no idea.
I have no idea either. I've heard
I mean,
Chelonia.
if it's Latin, it probably should be Colonia.
Yeah, probably. I never took Latin. I did have to memorize a lot of genus species combinations. All right, I know the turtle name, I know the date it was seen, I know the observer name, Dr. Boumediene and Peterson, right? So here's the fun part. This is the part I really love. So we do this graphically, right? And you have all this stuff in your book, your textbook, about SQL. And I would advocate that you shouldn't work directly with SQL, not at first, until you understand a lot of the concepts, work in a graphical environment. But then when you're ready to go SQL, you can turn this, instead of a datasheet view, into a SQL view. And what it does is it takes all of my relational algebra operations that I've done here, and that includes the relationship here, right? So embedded in this relationship is the one-to-many relationship. And if I change those other settings and I change it to the first join type or the second join type or the third join type, right? That changes everything. But watch what happens when I go to SQL view. It gives me all the SQL. So what am I saying? I can have a very complex query. I don't have to figure out how to write it in SQL. I can do it graphically, and if I need to change something or tweak something, then I can view the SQL and adjust from there. So what am I saying? You might have a SQL procedure that you load every time you need to generate data. And that would involve taking the SQL statements and creating a text file with it, and then processing it with the SQL command, SQL job, right? Or procedure, SQL job, or you run a SQL job or a SQL procedure. And if you want to change stuff quickly, you can just if you know what it is you're doing, you can just open this up, change whatever you need to, like the species ID. And oh, let's change this, right? I'm going to change it to 1. So I'll save it. Now I'll view it. Oh, I only get 1 type. I only get the leatherback, which is the species ID type of 1. So I wanted to take a little time to explain some of the extras here. Now, when you're doing this and following along in the video, you don't have to build the tables, you can import them. It's the external data. And so this is where you're exporting, but then here's import. So I want you to understand that new data source input from file, it looks a little different than the video. The video had an older version of Access, I think. But I wanted you to be aware that if you hold your pointer over it and you see export, that's a data table being exported out to a data file or a text file, right? And so if you have icons on your screen because you have an older version of Access, I want you to be aware, to be mindful of the arrow, and I want you to hold your mouse pointer over it, because when you start to follow along in the video, that can get confusing. Are there any questions about what we've shared with the Access internals before you attempt your 3.3 assignment?
None for me.
This is
Okay.
the assignment due Saturday, correct? 3.3.
Yes. This assignment, 3.3. So like a 20-minute video, then the screenshots that you follow along with. You know, it's good to look at the end to see what you're supposed to come up with at the end. But if you just watch the video and then look at the screenshots, you'll be like, oh yeah, I know, that's the next step, that's the next step, that's the next step. You don't have to have a detailed procedure. The observers and turtles files are the ones you import. It should be good to go. So that's the assignment. What are you doing for your solution? Under here, it's going to be a 3.4. So by Saturday, all right, so this is a try it on for size Access pilot, if you will, right? This is the first thing you're going to do with Access. Your solution is going to take the same kinds of steps, and you're going to build out the auction tables. So your solution is going to be worth 5 full points. It'll be 3.4 solution. And that's going to be due by next Tuesday at noon. So if you get this done first, the solution should come very easily for you. You'll have the same kind of resources. You'll have a video. You'll have a screen-by-screen, step-by-step graphics to work from, right? You'll have examples of what you're supposed to end up with for output. You'll have input files you can use to build your tables with. It'll be a little longer and a little more detailed, but this is learning how to ride a bike with training wheels, and your solution is, okay, we take the training wheels off. And this is just a two turtle, it might be a third table, but it's actually a pretty straightforward thing. So please take a look. If you have problems between now and Saturday, please send me an email that says I'm lost on this one step. And don't wait until the deadline, okay? Please? Everyone good?
I'm good.
All good.
Okay.
Yeah, got it.
Yeah.
Good.
I'm going to push this assignment back to like 11:59 tonight, the 3.2, in case anybody's still working on functions. And let me know if you need a little bit of wiggle room on the submission. Okay.
Professor Kenta,
Yes.
can you reset mine? The 3.2?
Right. Is this Deidre or
This is Kanisha.
Tanisha.
Yeah, me too.
Okay, it was Deidre as well, right?
Yeah.
Okay, you got it. I'll do it. I'll do it right now.
Thank you.
Yep. All right. Well, you have a good day. And
Okay, bye-bye.
yep.
Oh,
Well,
can you do 3.1 for me too? Because I messed up both submissions. So, and then I'll resubmit them right now.
okay. Who is this talking?
Okay. Deidre. Me.
Okay. Let me stop recording.